All right, welcome to Algebra II 522, and we're going to be talking about logarithms and inverses still. So last time we were talking about a very specific inverse, and we got that kind of log. Those are more formally called logarithms. So we're going to kind of focus on those again today. So right here I have a table, and this does follow a pattern of a logarithm. So what I want you to try and do is figure out what the pattern is. Once you have that pattern, then try and go through and fill out all of those missing blanks. And then we'll talk about it. So I'll see you in a bit. Okay, so what we find is that our pattern here is, there it is, 2 to the third power is 8. 2 to the negative 1 power is a half. 2 to the 6th power is 64. 2 to the 1/2 power is rad 2. So that's our pattern. Now, what it actually is equation-wise is log base 2. That's that little subscript number is the base of x is equal to the g of x here. So we can kind of use that information that can help us fill out the rest of these. So 2 raised to what power gives us 32? That's going to be 5. 2 raised to what power gives us 1? That's going to be 0. 2 raised to what power gives us 16? That's 4. 2 raised to what power gives us 4? That's 2. 2 raised to what power gives us 3? That one's not very easy, so we're going to come back to it. 2 raised to what power gives us 2? That's 1. 2 raised to what power is 0? We can't do that. It's impossible to have 2 raised to a power n and get 0. You also cannot get negative, so negative 1 is impossible for us as well. And then 0.25, if you think of it as 1/4, it might help, and that would be a negative 2 for the power. 0.2, same boat as 3. It's going to be very, very difficult to get. And then 1/8 is going to be negative 3 as our power. So I already kind of mentioned, well, 0 and negative 1, we can't get those because if I'm multiplying some number of 2's together, it's impossible for me to get 0 or a negative. Because the only way to get a 0 is if I'm multiplying by 0, and the only way to make that negative is if I'm multiplying by a negative, and I'm only multiplying by positive 2's. So neither of those can happen. So now 3 and 0.2, but we're only going to really look at 3 because it's the same process here, is going to be, well, we know it's somewhere between 4 and 2. Well, this gave us 2, and this gave us 1. So we know that the value has to be between 1 and 2. So this is where it effectively becomes a kind of a guess and check problem. I keep plugging in a bunch of just like try 1.5, try 1.6, try all these different numbers until they get a decent guesstimate for what it is. Now, you're never going to get it perfect, but you can get pretty darn close by kind of guessing and checking there. So I'm not going to have you do that right now, but that would be effectively the process for doing those. All right, so let's take a look at this one. So this one, same idea, but it's now log base 5. So these are all going to be 5 raised to this power equals this. 5 raised to this power equals this. 5 raised to this power equals this, and so forth. So first of all, find any others which you can know and are going to be nice, pretty whole numbers right now. Go ahead and pause and try and find those. There should be 2. Okay, and now that we're back, all the rest of these, we're going to have to do that kind of guess and check for it. So what I'm going to ask you to do is go ahead and try that for like 2 of them, just to get a feel for it, and then we'll move on. So go ahead and pause and try that out. Okay, so what I want you to kind of notice here, more than just the whole here's a bunch of guessing and checking, is the pattern, right? Right here, I'm changing my x very, very slightly, and I'm getting relatively large changes in my y value, or my g of x, right? Then as I keep going further right, it takes me a lot longer in my x changes to get the same change in my y. So from here to here, I'm moving less than like 1, and I'm increasing by 1, right? Here I'm increasing my x by 4. I'm 4 more than I was just to go up 1 in my y. And then here I'm increasing by 20 to go up to the next one, and then I'm increasing by 100 to go up 1. So it's kind of the exact opposite of an exponential, where exponential, the further right you get, the faster and faster it goes up, right? This is the opposite. The further right I get, the slower and slower it goes up. And that kind of makes sense because these are inverses of exponential. So they're going to do the exact opposite of what an exponential would do, right? So if we graph this, we get that kind of curve up, and then it kind of goes really flat, really fast to the right there. All right, so number 70, what I want you to do is, in your head, without a calculator, try and tell me what all of these question marks would be, just by using that like pattern of saying, well, this would be 2 raised to what power is 32. Try and answer all of those by doing that. Okay, so we're going to go ahead and do this. So 2 raised to what power is going to be 32? Well, that's going to be, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it takes 5 2s, so 2 to the 5th power. B, 2 to what power is 1/2? Well, that's going to be a negative 1, because remember those negative exponents give us the flipped fractions. On C, 2 to what power is 4? Well, that's going to be 2. D, 2 to what power is 0? We can't do that. It's impossible for us to get 0. Then E, 2 raised to the 3 is what? Well, 2 times 2 is 4, 4 times 2 is 8, so we're going to get 8 there. F, 2 to the 1/2 power is what? Well, that's going to be the square root of 2, because remember, fractional exponents give us radicals. And then G, 2 raised to what is the 1/16th? Well, to get a 16, that's to the 4th, so the negative will also flip that over. And then H, 2 to the 0 is what? Well, that's going to be a 1 for us. So hopefully we're feeling pretty good about doing those. Once you kind of get the pattern for how those all work together, they're really not all that bad. Last thing that we kind of want to go over here is this. So try that same thing. These are a little bit different, but try and answer them without a calculator, just by kind of working with what they are saying. All right, so A, 7 raised to what is 49? It's going to be the 2nd power. B, 3 raised to what is 81? That's going to be the 4th power. Then C, if you say it in the way that I've been, these are very, very easy. 5 raised to what power is 5 to the 7th power? Well, it has to be the 7th power. That makes sense, right? And then D, 10 raised to what power is 10 to the 1.2 power? Well, once again, it has to be 1.2. So the pattern that I want you to kind of see there is this. Both of these, that's happening because my base is the same as the inside, right? 5 and 5. Here, 10 and 10. And if that happens, I can just kind of do that little pattern where, like, oh, it's just going to be the exponent. So if I go down to E, I can say, well, these are both 2, so the answer is the exponent. I don't even have to bother trying that, well, 2 raised to what power is equal to 2 raised to the w plus 3. I can see, well, they're both 2, those cancel, it's w plus 3 as my solution there. Okay, that's one of the very first properties of logarithms we're going to start to cover next time as we kind of start to develop more and more skills with working with logarithms. Lastly, note-wise, the only real note that I really want to make sure you have is this one right here. Make sure you are able to convert from logarithmic form to exponential and vice versa. Being able to fluently go back and forth will make working with logarithms so much easier going forward. So I just want to make sure you're feeling confident there. All right, so with that, here is our homework, 73 through 80, and I will talk to you guys next time.